Voltage regulators stabilize voltage levels within a specific range, for example, 110 to 120 volts. They protect against both overvoltage and undervoltage conditions. Overvoltage protectors trip and cut off power when voltage exceeds a predetermined threshold, such as 140 volts. They are often combined with surge suppression capabilities. To address your specific problem, firstly consider a voltage regulator with overvoltage protection. Install a voltage regulator that provides both voltage stabilization and overvoltage protection. Look for models with a wide voltage tolerance range and a high surge suppression rating. Secondly, an inline overvoltage protector can be used. Connect an inline overvoltage protector between the battery charger and the power source. Choose a model with a voltage threshold that corresponds to the acceptable voltage range for your charger, for example, 110 to 120 volts. Thirdly, a smart power strip with voltage monitoring can be used. Use a smart power strip with voltage monitoring capabilities. It will automatically cut off power when voltage levels fluctuate outside a safe range. The Triplite iSten 60PRO is a voltage regulator with overvoltage protection. The Klein Tools SVR408 is an inline overvoltage protector. The Belkin B10805 is a smart power strip with voltage monitoring. Ensure proper grounding and wiring of the outlet. Use surge protectors to protect against transient voltage spikes. Consider using a voltage meter to monitor the voltage levels at the outlet regularly. If you are not confident working with electrical equipment, consult a qualified electrician. It is crucial to understand the role of fuses and circuit breakers. These devices primarily protect against overcurrent conditions, meaning excessive amperage. While they offer a degree of protection against some voltage-related issues that result in overcurrent, they are not designed to be the primary defense against overvoltage situations. Surge strips and surge protectors are designed to mitigate transient overvoltages, which are short-duration spikes or surges in voltage. However, they may not be effective against sustained overvoltage conditions. For sustained overvoltage protection, devices like voltage regulators and overvoltage protectors are more suitable. When selecting a voltage regulator, consider the input voltage range, output voltage stability, and surge suppression capabilities. The input voltage range specifies the range of voltage that the regulator can accept and still provide a stable output. Output voltage stability refers to how well the regulator maintains a consistent output voltage despite variations in the input voltage or load. Surge suppression capabilities indicate the regulator's ability to protect against voltage spikes and surges. For inline overvoltage protectors, the key specifications to consider are the voltage threshold, response time, and surge current capacity. The voltage threshold is the voltage level at which the protector will trip and cut off power. The response time is the time it takes for the protector to react to an overvoltage condition. Surge current capacity indicates the maximum surge current that the protector can handle without being damaged. Smart power strips with voltage monitoring typically offer adjustable voltage thresholds, allowing you to customize the protection based on the specific requirements of your equipment. They may also provide features like remote monitoring and control, allowing you to track voltage levels and switch off power remotely. When installing any voltage protection device, ensure that it is properly grounded and wired according to the manufacturer's instructions and local electrical codes. Improper grounding or wiring can compromise the effectiveness of the device and create a safety hazard. Regularly inspect the device for any signs of damage or wear and replace it if necessary. If you are unsure about any aspect of voltage protection or electrical safety, consult a qualified electrician. They can assess your specific needs and recommend the most appropriate solutions for your situation. Understanding voltage, current, and resistance is essential for comprehending electrical safety and the operation of voltage protection devices. Voltage, measured in volts, is the electrical potential difference between 2 points. It is the driving force that causes electric current to flow. Current, measured in amps, is the rate of flow of electric charge. It is the amount of electricity flowing through a circuit. Resistance, measured in ohms, is the opposition to the flow of electric current. It limits the amount of current that can flow through a circuit. Ohm's law describes the relationship between voltage, current, and resistance, which states that voltage equals current times resistance. Understanding Ohm's law can help you troubleshoot electrical problems and select appropriate voltage protection devices. Overvoltage conditions can damage sensitive electronic equipment by exceeding their voltage tolerance. This can lead to component failure, reduced lifespan, or even fire hazards. Voltage protection devices prevent damage by limiting the voltage that reaches the equipment. They do this by either stabilizing the voltage or cutting off power when the voltage exceeds a safe level. Different types of equipment have different voltage tolerance ranges. Check the manufacturer's specifications for the acceptable voltage range of your equipment before selecting a voltage protection device. Some equipment may be more sensitive to voltage fluctuations than others. For example, electronic devices with microprocessors or integrated circuits are typically more sensitive than simple appliances like lamps or heaters. In addition to voltage protection devices, surge protectors can help protect against transient voltage spikes caused by lightning strikes or other electrical disturbances. Surge protectors divert excess voltage away from the equipment, preventing it from reaching damaging levels. It is important to use surge protectors in conjunction with voltage protection devices to provide comprehensive protection against all types of voltage fluctuations. When choosing a surge protector, consider the surge current capacity, clamping voltage, and response time. Surge current capacity indicates the maximum surge current that the protector can handle without being damaged. Clamping voltage is the voltage level at which the protector starts to divert excess voltage. Response time is the time it takes for the protector to react to a voltage surge. In addition to voltage protection devices and surge protectors, proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Ensure that all electrical outlets and equipment are properly grounded according to local electrical codes. If you are unsure about the grounding of your electrical system, consult a qualified electrician. Regular electrical inspections can help identify potential hazards and ensure that your electrical system is operating safely. During an electrical inspection, a qualified electrician will check for faulty wiring, overloaded circuits, and other electrical problems. They can also recommend improvements to your electrical system to enhance safety and efficiency. When working with electrical equipment, always follow safety precautions to prevent electrical shock. Turn off the power before working on any electrical circuit. Use insulated tools and wear appropriate personal protective equipment such as rubber gloves and safety glasses. If you are not comfortable working with electrical equipment, consult a qualified electrician. Never attempt to repair or modify electrical equipment unless you are properly trained and qualified. Electrical work can be dangerous, and improper repairs can lead to electrical shock or fire hazards. By taking appropriate precautions and using voltage protection devices, you can protect your sensitive equipment and ensure electrical safety in your home or workplace. Remember that electrical safety is an ongoing process, and it is important to stay informed and up to date on the latest safety practices. Also note the National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. Familiarize yourself with the relevant sections of the NEC to ensure that your electrical system complies with current safety standards. Some NEC tables related to the topic are Table 310.15. B16, which provides ampacity ratings for insulated conductors rated up to and including 2000 volts, and Table 250.122, which specifies the minimum size of equipment grounding conductors for grounding electrical equipment. Different types of voltage regulators are available, including ferrosonant regulators, electronic tap switching regulators, and solid-state regulators. Ferrosonant regulators use a transformer with a saturated core to provide voltage regulation. They are known for their ruggedness and reliability, but they can be bulky and inefficient. Electronic tap switching regulators use a series of taps on a transformer to adjust the output voltage. They offer better efficiency and regulation than ferrosonant regulators, but they can be more complex and expensive. Solid-state regulators use electronic components to regulate the output voltage. They offer the best efficiency and regulation, but they can be more sensitive to overloads and voltage spikes. Inline overvoltage protectors are typically small and compact, making them easy to install between the power source and the equipment being protected. They use a variety of technologies to detect and suppress overvoltage conditions, including metal oxide varistors, or MOS, and silicon avalanche diodes, or SADs. MOV are commonly used in surge protectors to divert excess voltage away from the equipment. SAD offer faster response times and lower clamping voltages than MOV, but they can be more expensive. Smart power strips with voltage monitoring typically use a microprocessor to monitor the voltage level and control the power to the connected equipment. They may also offer features like energy monitoring, surge protection, and remote control via a smartphone app. When selecting a smart power strip, consider the number of outlets, surge protection rating, and energy monitoring capabilities. Ensure that the power strip is rated for the voltage and current requirements of your equipment. Overvoltage protection is crucial for safeguarding sensitive equipment against damage from voltage fluctuations. Voltage regulators, overvoltage protectors, and smart power strips offer effective solutions for maintaining stable voltage levels and preventing overvoltage conditions. By understanding the principles of voltage protection and selecting appropriate devices, you can protect your valuable equipment and ensure electrical safety in your home or workplace. The correct wiring of electrical outlets is critical for safety and proper operation of electrical equipment. A standard 120-volt outlet has 3 terminals: a hot terminal, a neutral terminal, and a ground terminal. The hot terminal is connected to the ungrounded conductor, which carries the electrical current from the power source. The neutral terminal is connected to the grounded conductor, which provides a return path for the electrical current. The ground terminal is connected to the grounding conductor, which provides a path for fault current to flow back to the source. The hot terminal is typically identified by a black wire, the neutral terminal by a white wire, and the ground terminal by a green or bare wire. It is essential to connect the wires to the correct terminals to prevent electrical shock and equipment damage. If you are unsure about the wiring of an electrical outlet, consult a qualified electrician. Incorrect wiring can create a dangerous situation and lead to serious consequences. When testing an electrical outlet with a voltmeter, you should measure approximately 120 volts between the hot and neutral terminals, approximately 120 volts between the hot and ground terminals, and approximately 0 volts between the neutral and ground terminals. If you measure a different voltage, there may be a wiring problem or a voltage fluctuation in the electrical system. Investigate and correct any wiring problems before using the outlet. Remember, electrical work can be dangerous, and it is always best to consult a qualified electrician if you are unsure about any aspect of electrical safety. Voltage protection devices are essential tools for protecting sensitive equipment from damage caused by voltage fluctuations. By understanding the different types of voltage protection devices and their applications, you can make informed decisions about how to protect your valuable equipment and ensure electrical safety.